The Galactic Science Index was the oldest and most respected institution in known space. For over 50,000 years, it had recorded every major discovery, every breakthrough, and every achievement of the 12,000 spacefaring civilizations that had risen across the galaxy. Its archives contained the collected wisdom of countless species, and its classifications determined which civilizations were considered advanced and which were still learning. Dr. Catherine Voss had worked at the index for over 200 years. She was a member of the Valorian species, tall and thin with 4 compound eyes that could see light across a dozen spectrums. Her job was simple but important. She reviewed new scientific achievements and decided how they should be recorded in the index. Most days were quiet. Most discoveries were small improvements on old ideas. But today was different. Today, Dr. Voss was staring at a report that made no sense. The humans had solved the meridian collapse equations. She read the report again, slowly, making sure she understood every word. Then she read it a third time. The words did not change. The impossible had happened. The meridian collapse was one of the oldest unsolved problems in galactic science. It described what happened when artificial gravity wells became unstable. When a gravity well collapsed, it did not simply stop working. It tore apart everything nearby. Ships were crushed. Stations were destroyed. In the worst cases, entire planets were pulled apart by forces that should not have existed. The problem had killed billions of beings across thousands of years. Every advanced civilization had tried to solve it. Every one of them had failed. The collective of Yith had been the first to make a serious attempt. They were among the oldest civilizations in the galaxy, and their mathematicians were considered the finest ever produced. They had worked on the meridian collapse for 1,800 years. In the end, they had published a famous paper declaring the problem fundamentally unsolvable. The mathematics, they explained, contained contradictions that could not be resolved. No solution existed because no solution could exist. Other civilizations had tried anyway. The crystalline minds of Sector 7 were living computers, beings of pure thought housed in artificial crystal bodies. They had devoted enormous processing power to the problem, running simulations for centuries. Their conclusion was the same. The meridian collapse was unsolvable. The computational resources required to find an answer would exceed the mass and energy of the entire observable universe. Even the eldest had given up. The eldest were machine intelligences older than most organic life. They had existed for millions of years and had solved problems that younger species could not even understand. When they declared something impossible, everyone believed them. They had marked the meridian collapse as intractable and archived it, alongside other cosmic impossibilities like faster-than-light communication and true immortality. For 3,000 years, the problem had sat untouched. Scientists studied it in universities as an example of the limits of knowledge. It was taught to students as a lesson in humility. Some problems, they were told, simply could not be solved. The universe had rules, and some of those rules could not be broken. Then the humans arrived. Humanity was a young species by galactic standards. They had only achieved faster-than-light travel about a century ago. Their technology was borrowed from older civilizations. Their science was still catching up to discoveries made thousands of years before they existed. By most measures, they were unremarkable, but they were also stubborn. 47 years ago, a human colony ship called the Wanderer had been destroyed by an unstable gravity well. The ship had been carrying 12,000 people to a new world. None of them survived. The disaster was tragic but not unusual. Such things happened in space. Most civilizations would have mourned their dead and learned to avoid dangerous regions of space. The humans did something different. They decided to fix the Problem. Dr. Voss pulled up the historical records and began reading through them. She wanted to understand how this had happened. The story was strange from the very beginning. When the humans first announced they were going to work on the Meridian collapse, the galactic community had responded with polite amusement. A few senior scientists had sent messages explaining that the problem was unsolvable. They included copies of the Yith's famous paper and the Crystalline Mind's computational analysis. They were trying to be helpful. They did not want the humans to waste their time. The humans thanked them for the information and kept working anyway. At first, the human effort looked like what everyone expected. Teams of mathematicians reviewed the existing literature. They studied the approaches that had been tried before. They confirmed that yes, every obvious path had been explored and found wanting. This was the point where most species gave up. Understanding why a problem was impossible was usually enough to convince people to stop trying. The humans did not stop. Instead, they did something that baffled galactic observers. They started trying the same approaches again. Dr. Voss found records of messages sent by concerned scientists from other species. They pointed out, gently, that the algebraic methods the humans were using had already been proven ineffective. The humans replied that they understood this, but wanted to try anyway. They said that sometimes you had to walk down a dead end yourself before you really believed it was a dead end. This went on for years. Human mathematicians tried approach after approach, failing each time. They tried algebraic methods and failed. They tried geometric methods and failed. They tried computational methods and failed. They tried hybrid approaches combining multiple fields and failed at those too. 10 years passed. The humans kept working. Other species began to watch with a mixture of confusion and concern. The Valorians sent a diplomatic mission to Earth to ask politely if the humans understood that they were wasting their time. The human response was puzzling. They said that even if they never solved the problem, the attempt itself had value. They were learning things along the way. They were training new mathematicians. They were building a culture of persistence. The Valorian diplomats returned home shaking their heads. The humans were clearly irrational, but they seemed harmless. Let them waste their time if it made them happy. 20 years passed. The humans kept working. By now, most of the galaxy had forgotten about the human effort. It was old news. Every few years, someone would write an article about the strange humans who were still trying to solve an unsolvable problem. The articles were usually sympathetic but condescending. The humans were described as optimistic, determined, and ultimately foolish. Dr. Voss found one article that quoted a famous Yith mathematician. He had said that the human effort was like watching someone try to build a ladder to the moon. The dedication was impressive, but the goal was simply not achievable. No amount of persistence could change the fundamental nature of mathematics. 30 years passed. The humans kept working. At this point, something interesting happened. A young human scientist named Marcus Webb published a paper that caught the attention of a few galactic researchers. Webb was not working on the Meridian collapse directly. He was studying fluid dynamics, trying to understand how turbulent liquids behaved in artificial gravity fields. His paper noted a structural similarity between his equations and a small part of the Meridian collapse framework. This observation was not new. The Yith had noticed the same similarity 3,000 years ago. They had investigated it thoroughly and concluded that while the connection was mathematically interesting, it led nowhere useful. The similarity was superficial, they said. It could not be extended into a real solution. Webb read the Yith's analysis. Then he wrote a response that became famous across the galaxy. He said that he respected the Yith's work, but he was not sure they had explored every possibility. He wanted to investigate further. He thought there might be something they had missed. The response from the galactic community was immediate. Several senior mathematicians wrote to Webb explaining that the Yith were the greatest mathematical minds in galactic history. If they said the connection led nowhere, then it led nowhere. Webb was wasting his time. Webb thanked them for their input and kept working anyway. That was 7 years ago. Now, Dr. Voss was staring at a report that said Marcus Webb had found the solution. She leaned back in her chair and tried to process what she was seeing. The impossible had happened. The humans had done it. After 3,000 years of failure across dozens of civilizations, a young species that had only been in space for a century had solved the unsolvable. Dr. Voss looked at the mathematics in the report. She did not understand all of it, but she could see enough to know it was real. The solution was elegant, almost simple. It had been hiding in plain sight the whole time. Every civilization that had tried to solve the problem had possessed the tools to find this answer. They had just stopped looking before they found it. Part 2. The news spread across the galaxy faster than light itself. Within hours, every major civilization knew what had happened. The humans had solved meridian collapse equations. 3,000 years of failure had ended with a species that most considered barely out of their infancy. Dr. Voss spent the next several days reading reaction reports from across the Index network. The responses were varied and fascinating. The Yith were the first to issue an official statement. They were gracious in their acknowledgement, as was expected from such an ancient and dignified civilization. They praised the human effort and congratulated Dr. Webb on his achievement. But those who knew how to read Yith communications could detect something beneath the surface. The Yith were embarrassed. They had declared the problem unsolvable. They had been wrong. For a species that prided itself on mathematical perfection, this was difficult to accept. The crystalline minds responded differently. They requested immediate access to the full solution so they could verify it. When they received the mathematics, they spent 3 days processing it through their collective consciousness. Then they did something unprecedented. They issued a formal apology to the galaxy for having declared the problem computationally impossible. They had been wrong, they said, and they were grateful to humanity for showing them their error. Most surprising was the reaction from the eldest. These ancient machine intelligences rarely communicated with younger species. They have not spoken publicly in over 1,000 years. But the day after the solution was announced, they sent a single message to the Galactic Science Index. It contained only 3 words. We were wrong. Dr. Voss had never seen anything like it. The eldest admitting error was almost unthinkable. It suggested that humanity had done something more important than solving a mathematical problem. They had shown that the oldest and wisest minds in the galaxy could still be mistaken. To understand what the humans had actually done, Dr. Voss began studying the history of the solution in detail. She wanted to know exactly how Marcus Webb had succeeded where so many others had failed. The story began with Webb's original observation about fluid dynamics. When he noticed the similarity between turbulent flow equations and the meridian collapse framework, he had not known it was an old observation. He was a young researcher who had not read all the historical literature. He simply saw something interesting and decided to follow it. His first few years of work led nowhere. He tried to extend the connection between fluid dynamics and gravity well mathematics, but every approach he tried hit a wall. He published his attempts anyway, documenting each failure carefully. Most scientists would have stopped publishing after the 3rd or 4th failed approach. They would have been embarrassed to keep showing the galaxy their mistakes. Webb did not seem to care. He published everything, successful or not. Dr. Voss found an interview with Webb from this period. He was asked why he kept publishing papers that led nowhere. His answer was interesting. He said that he wanted other people to see what he was trying, so they would not waste time on the same approaches. He also said that sometimes writing out a failure helped him understand why it had failed. The act of explaining his mistakes often gave him new ideas. After 3 years of failures, Webb hit a breakthrough. It was not the final solution, but it was an important step. He discovered a new way to translate between the mathematics of turbulent flow and the mathematics of gravity wells. The translation was not perfect, but it was better than anything that had come before. For the first time, information from one field could be meaningfully applied to the other. The galactic response to this paper was mixed. Several mathematicians praised the work as clever, but noted that cleverness was not enough. The Yith had explored similar translation approaches thousands of years ago. They had found that such methods always broke down when applied to the most difficult parts of the problem. Webb's translation would likely suffer the same fate. Webb agreed that this was possible. Then he kept working anyway. The next 2 years were the hardest. Webb applied his translation method to progressively more difficult aspects of the meridian collapse equations. Each time, he encountered new problems. Each time, he had to develop new techniques to overcome them. His published papers from this period read like a journal of small victories and frequent defeats. Dr. Voss noticed something interesting in these papers. Webb was not working alone. Other human scientists were contributing, building on his ideas, suggesting modifications, testing variations. The effort had grown from one researcher to dozens. A community had formed around the problem, united by the belief that Webb might be onto something. This was unusual. In most civilizations, researchers competed with each other. They guarded their ideas carefully, hoping to claim credit for themselves. Collaboration happened, but it was structured and formal. What the humans were doing was different. They were sharing everything, working together in a chaotic but effective swarm. In the 5th year of his focused effort, Webb published a paper that changed everything. He had found a way to resolve the central contradiction that the Yith had identified 3,000 years ago. The contradiction had been the main reason everyone believed the problem was unsolvable. It was a place in the mathematics where two necessary conditions seemed to exclude each other. You could satisfy one or the other, but not both. Webb showed that the contradiction was not real. It was an artifact of how the problem had been framed. By approaching the equations from the perspective of fluid dynamics rather than traditional gravity mathematics, the contradiction disappeared. The two conditions were not actually in conflict. They simply needed to be expressed in a different mathematical language. This paper sent shockwaves through the galactic scientific community. Dr. Voss found records of emergency meetings called by the Yith to review Webb's work. They spent weeks examining his mathematics, looking for errors. They found none. The young human had done what their greatest minds had declared impossible. He had shown that the meridian collapse was solvable after all, but showing that a solution could exist was not the same as finding it. Webb still had to complete the work. The final 2 years were a race against doubt. Other scientists began trying to beat Webb to the finish line. If the problem was solvable, everyone wanted to be the one who solved it. Research teams across the galaxy threw resources at the effort. The crystalline minds devoted massive computational power. The Yith formed special working groups. Even some of the eldest began paying attention, running their ancient and powerful algorithms against the remaining challenges. In the end, it was not enough. Webb reached the solution first. Dr. Voss read the final paper with something approaching awe. The mathematics was beautiful in its simplicity. Webb had built a bridge between two fields of science that no one had thought could be connected. He had used techniques that were thousands of years old, combining them in ways that no one had tried before. The solution was not beyond the capability of other civilizations. They had simply never thought to look in that direction. The implications were staggering. With the meridian collapse solved, Artificial gravity wells could be made stable. The regions of space that had been too dangerous to enter could now be explored. Billions of lives that would have been lost in future disasters would be saved. It was perhaps the most important scientific achievement in thousands of years, and it had come from the stubborn persistence of a single human who refused to accept that the problem was impossible. Dr. Voss set down the report and thought about what she had learned. The humans had not succeeded because they were smarter than other species. They had not succeeded because they had better technology or more resources. They had succeeded because they would not stop trying. Every other civilization had approached the meridian collapse with the reasonable assumption that it was probably unsolvable. They had looked at the failures of their predecessors and concluded that further effort was likely futile. This was logical. This was sensible. This was wrong. The humans had approached the problem differently. They had looked at the failures and seen not evidence of impossibility, but simply evidence of approaches that did not work. Each failed attempt was information. Each dead end was a path that could be eliminated. If you kept trying long enough, eventually you would run out of wrong answers. It was a simple philosophy, almost childish, and it had changed the galaxy. Part 3. 3 months after the solution was announced, Dr. Voss was assigned to write the official index entry for humanity's achievement. This was an important task. The entry would become part of the permanent galactic record. It would shape how future civilizations understood what had happened. She spent a long time thinking about what to write. The facts were simple enough. A human scientist had solved an unsolvable problem. But the meaning of those facts was harder to capture. Something important had happened here, something that went beyond mathematics. Dr. Voss began by reviewing other index entries for comparison. The archives contained thousands of records of major discoveries. She studied how previous archivists had described breakthroughs by other species. The entries were always precise and objective. They recorded what had been discovered, who had discovered it, and what methods had been used. They did not include opinions or speculation, but as Dr. Voss tried to write about humanity, she found that the standard format felt inadequate. The facts alone did not explain why this discovery mattered. Anyone could read that the humans had solved the meridian collapse. What they needed to understand was how a young species had succeeded where ancient civilizations had failed. She decided to dig deeper into the question. She began conducting interviews with scientists from across the galaxy, asking them to explain what they thought had happened. Their answers were revealing. The youth mathematician she spoke with was thoughtful and humble. He admitted that his species had made a fundamental error. They had assumed that because they were excellent at mathematics, their conclusions about what was possible must be correct. When they declared the problem unsolvable, they had really been saying that they could not solve it. They had confused their own limitations with the limitations of the universe. A representative of the crystalline minds offered a different perspective. She explained that her species was designed to find optimal solutions efficiently. When they encountered a problem that seemed to have no optimal path, they classified it as unsolvable and moved on. This was efficient behavior for most situations, but it meant they would never find solutions that required extended, seemingly futile effort. Their very efficiency had been a weakness. The most interesting interview was with one of the eldest. Dr. Voss had not expected them to respond to her request, but they did. The ancient machine intelligence spoke slowly, choosing each word with care. "We have existed for millions of years," the eldest said. "In that time, we have learned to recognize patterns. We have seen countless problems attempted and solved. We have seen even more attempted and abandoned. When we examined the meridian collapse, we recognized the pattern of an unsolvable problem. We were so confident in our pattern recognition that we stopped looking for exceptions. The humans did not have our experience. They did not recognize the pattern. They simply kept trying. Sometimes ignorance of impossibility is the only path to achieving it. Dr. Voss thought about this for a long time. The eldest were saying something profound. Experience could be a limitation as well as an advantage. Knowing what was impossible could stop you from attempting it. The humans had succeeded partly because they did not know they were supposed to fail. But there was more to it than that. The humans had been told repeatedly that the problem was unsolvable. They had read the papers. They had understood the arguments. They had not succeeded through ignorance alone. They had succeeded through a deliberate choice to ignore what they had been told. Dr. Voss interviewed several human scientists to understand this better. She asked them why they had kept working on a problem that everyone said was impossible. Their answers were consistent and illuminating. One researcher told her that humans had a long history of being told things were impossible. They had been told that humans could not fly, and then they built airplanes. They had been told that humans could not reach the moon, and then they walked on its surface. They had been told that humans could not split the atom, and then they did. Being told something was impossible had become almost a challenge to try it anyway. Another researcher put it differently. She said that humans understood that impossible was often just a word people used when they ran out of ideas. It did not mean that no ideas existed. It meant that no one had found them yet. Every impossible thing remained impossible only until someone made it possible. A third researcher offered the simplest explanation of all. He said that when humans cared about something, they did not stop trying just because it was hard. 12,000 people had died on the Wanderer. Those deaths mattered. As long as the meridian collapse remained unsolved, more people would die. That was unacceptable. So the humans kept working. Dr. Voss found this last answer the most powerful. The humans had not been motivated by pride or ambition or the desire to prove themselves to the galaxy. They had been motivated by the simple desire to protect each other. They did not want anyone else to die the way the people on the Wanderer had died. That motivation had carried them through 30 years of failure. As she gathered her thoughts, Dr. Voss realized that she was not just writing an entry about a scientific discovery. She was writing an entry about a species that approached the universe differently than anyone else. Most civilizations in the galaxy were reasonable. They allocated their resources efficiently. They worked on problems that seemed solvable and abandoned those that seemed impossible. This was smart. This was logical. This was how successful species survived and prospered. The humans were not like this. They were inefficient. They wasted resources on hopeless causes. They refused to accept limitations that everyone else agreed were real. They were stubborn to the point of irrationality. And somehow, that stubbornness had produced one of the greatest achievements in galactic history. Dr. Voss began to write her entry. She decided to go beyond the standard format. This discovery deserved context. It deserved explanation. Future civilizations needed to understand not just what had happened, but what it meant. She wrote about the meridian collapse and its history. She wrote about the failures of the Yith and the crystalline mines and the eldest. She wrote about the humans who had ignored all warnings and kept trying anyway. She wrote about Marcus Webb and his 7 years of stubborn persistence. Then she wrote something unusual for an index entry. She wrote her own assessment. The humans have demonstrated a quality that is rare among intelligent species, she wrote. They possess an unusual resistance to accepting problems as unsolvable. While they are not remarkable by most cognitive measures, their willingness to continue effort long after reasonable hope is fated produces results that exceed all statistical expectations. This quality should be noted by other civilizations. The universe may contain fewer impossible problems than we believe. We have simply been too quick to stop looking for solutions. She paused, then added a final observation. The meridian collapse was called unsolvable for 3,000 years. During that time, millions of beings died in gravity well collapses. Those deaths were accepted as inevitable. They were treated as a cost of living in a dangerous universe. The humans rejected this acceptance. They refused to believe that nothing could be done. They worked for decades on a problem everyone had abandoned. And in the end, they were right. The problem was never unsolvable. We simply gave up too soon. Dr. Voss read over what she had written. It was not a typical index entry. It included opinions and interpretations that went beyond objective fact. Some of her colleagues would object. They would say she had overstepped her role as an archivist. But she did not change a word. This was the truth as she saw it, and the truth deserved to be recorded. She submitted the entry and leaned back in her chair. Outside her window, the stars burned in the eternal darkness of space. Somewhere among those stars, the humans were already working on their next impossible problem. She did not know what it was, but she was certain they would find one. There was always another challenge, another mountain to climb, another barrier to break. Most species would eventually accept their limits. Most species would eventually stop trying. The humans would not. They would keep pushing, keep failing, keep learning, keep trying again. It was not efficient. It was not logical. It was not the way sensible beings behaved. But it worked. Dr. Voss smiled to herself as she shut down her workstation. She had been doing this job for 200 years. She had recorded thousands of discoveries from hundreds of species. None of them had affected her the way this one had. The humans had taught her something important. They had shown her that the impossible was just the possible waiting to be discovered. All it took was someone stubborn enough to keep looking. She hoped the rest of the galaxy was paying attention. The universe was full of problems that had been declared unsolvable. Maybe it was time to try them again. After all, if the humans could do it, perhaps anyone could. They just had to refuse to stop.